So Bharani, what can you tell us about time series with vis-a-vis the projects that you have done, and any interesting insights that you have had from time series? Over to you, Bharani. First.
Ah, yeah. So when it comes to time series, Nitin, there are multiple options that one has to figure out. One is a client, a new client who is outsourcing the project for the first time? Are the processes to capture the data intelligently devised? Are they mature enough? Are people automatically capturing the data, or is it a manual way of capturing the data? Are you doing a project for a client in a country where there is too much of volatility? Or are you doing projects for customers in countries where the processes are well set up for that industry? So whole lot of things go into picture, not just time series, for any other algorithm as well, but for time series it will be even more important, given that you would be capturing every data point, probably every second or every minute or every day, based on some frequency you'd be capturing continuously. And whenever you want to forecast the next data point, you need access to the previous data point. For sure. I mean, the time series data, Jan, Feb, March, April, May, June, July, August, September, October. And then if you want to predict for November, you need October data. So it becomes very imperative that you pay utmost attention to the quality of the data and how it is captured. Okay. This is point number one. Point number two is, usually when it comes to time series, we deal with a single variable of interest. If you're forecasting sales, only sales, that will be the key variable. However, people look outwards and try to get additional variables which might impact sales, like probably number of products, or maybe number of footfalls, number of people visiting the store, or number of people accessing the e-commerce portal. If you try to get those additional variables and include those also within your model, and then if you try to build a time series model, then it's called as econometric model. And econometric models are widely preferred. Okay, that's one point. And here, there are two things, once again, to deal with the time series datasets. One is go with your traditional techniques, traditional models which exist. Another is go with the deep learning models. When it comes to traditional models, we have data-driven approaches, model-driven approaches, right? And then you have naive forecast technique, moving average technique, exponential smoothing technique, and bunch of other things. And on the other side, when it comes to deep learning, we have techniques such as LSTM, long short-term memory. You have bidirectional LSTM. We have deep bidirectional LSTM. On similar lines, you have RNN, bidirectional RNN, deep bidirectional RNNs, GRUs, gated recurrent units. And now the new breed of algorithms which are used to forecast are transformer techniques. BERT model from Google, GPT models from OpenAI, right? And OPT, which is from Facebook, and whole lot of algorithms are available now, and the accuracies of which are just skyrocketing. But then we have to bear in mind that the moment we use deep learning, accuracy will be very high because it's going to learn very difficult or wide varied patterns as well. But we need to compromise on the explainability. So that's a call that we need to take. And here also, we have techniques such as auto ARIMA techniques, which are used to automate the various algorithms which are built. And then it's going to give you one set of combinations, hyperparameters, which will give you the best results. So I would say any algorithm that we choose, Now, in the current world, the way the world is enhancing, we need to look out for auto ML techniques, auto EDA techniques, auto pre-processing techniques, because the sooner you complete the project, the better it is for us. Right? So, yep. So these are a few insights from time series standpoint.
Okay. So time series, friends, if you by the excuse me, by the inputs provided by Bharani. All right. So time series is like it's not a master's degree or an MS or an MD. It is probably a double or a triple MD that one would require to do to be able to get the gist of thing, because that's like a huge area of work and development and study and activity in itself. Another huge area of activity that I see is in the space of image processing and in the black box techniques, especially in the CNN space. So I'd like Sharath, if you could throw some light on what are the things with reference to CNN at a high level. What is the expectation, etc. Post which, like we said, we'll be moving deeper in subsequent sessions.
Thank you, Nitin. I think I'll give the answer in brief. When we talk about deep learning algorithms and the world of machine learning as such, we have a lot of problems solved in the space of image and video analytics. So CNN actually revolutionized the processing of image data. That's how I would personally see. And from there on, it has like never looked back. It's improving. And convolutional neural networks, of course, to understand this, we need some kind of a basic understanding on how a computer looks at an image. So there's something called as computer vision. These concepts are required. Yeah, sorry about that Diwali special background noise. Happy Diwali, everyone. All right, so coming back to the CNN, right? So as I said, we need to see how images are actually seen from a vision of a computer, right? We have to start from there. And as I said, we will be going in detail for discussing these algorithms step by step. And I mean, image data, right? So we have a lot of readily available pre-trained algorithms which can be used for the problem solving in our case, any business case that we talk about. So it's kind of you take readily available models, use them for your data. Of course, we will have to try and enhance the data that we have. A lot of annotation has to happen, ensure that varied conditions are considered, and we bring the data in for training purpose. We retrain the pre-trained models. This is the basic flow that we generally go ahead with. Retrain the algorithm. And then once the training is completed, we basically take the weights that are obtained, and using those weights, we'll try to predict on new data. Now, accuracy will not be a big problem here. As Bharani said, these algorithms are trying to learn the varied features from our data set. So accuracy is not going to be any problem. But I would definitely want to bring up one point that probably I missed, which is reproducibility of the algorithms. And we will probably discuss more about this in next session. I would definitely want to throw more information on this. So that's with respect to CNN, and I'm just trying to build curiosity here to bring up the important aspects of the machine learning model model development in an interview perspective. So how would you reproduce the models with same performance? So this is something that we should be discussing more, Nathan. That's my point.
Thank you. Thank you, Sharath.